In this video, we will explore how we use binocular and monocular cues to perceive the world in 3 dimensions and perceive motion. Depth perception is the ability to see objects in 3 dimensions, although the images that strike the retina are 2-dimensional. It allows us to judge distance. To perceive depth, we use 2 types of cues: binocular cues and monocular cues. Binocular cues are depth cues such as retinal disparity that depend on the use of 2 eyes. Comparing images from the retinas in the 2 eyes, the brain computes distance, the greater the disparity, between the 2 images, the closer the object. Monocular cues are depth cues such as interposition and linear perspective that are available to either eye alone. Here's an activity. With both eyes open, hold 2 pens or pencils in front of you and touch their tips together. Now do so with one eye closed. With one eye, the task should become noticeably more difficult. This demonstrates the importance of binocular cues in judging the distance of nearby objects. 2 eyes is better than 1. We are able to perceive depth because we have 2 eyes in front of our heads. Animals with eyes on the sides of their heads need that type of vision to scan for danger around them. Peripheral vision is much better at detecting motion, so stronger peripheral vision through eyes on the sides of the head gives an evolutionary advantage to animals that are typically hunted. Predators do not need to be on the lookout for danger. They are the danger. They need to determine distances between them and their prey, which requires the depth perception that binocular vision provides. Over the next few slides, we will examine the monocular depth cues in a little more detail. Relative height states that we perceive objects higher in our field of vision as farther away. Relative size states that if we assume 2 objects are similar in size, most people perceive the one that casts the smaller retinal image as farther away. This can be seen in the picture with the cars. Interposition states that if one object partially blocks our view of another, we perceive it as closer. Relative motion states that as we move, objects that are actually stable may appear to move. If, while riding on a bus, you fix your gaze on some point, say a house, the objects beyond that fixation point will appear to move with you. Objects in front of the point will appear to move backwards. The farther an object is from the fixation point, the faster it will seem to move. Linear perspective states that parallel lines appear to meet in the distance. The sharper the angle of convergence, the greater the perceived distance. And finally, with regards to light and shadow, shading produces a sense of depth consistent with our assumption that light comes from above. If you look at the top circle, it looks like a hill. The bottom circle is indented, all because of where the shadow and the light are. Another construct that helps us organize our sensations into meaningful perceptions is perceptual consistency. Perceptual consistency is perceiving objects as unchanging, having constant shapes, sizes, and brightness, even as illumination and retinal images change. 2 major characteristics that contribute to perceptual constancy are color and brightness, and shape and size. Over the next couple slides, we will examine both of these. Color constancy is perceiving familiar objects as having consistent color, even if changing illumination alters the wavelengths reflected by the object. Believe it or not, these 3 brown discs are identical in color. If we were to remove the surrounding tiles, you would see that all 3 are the same. Sometimes an object whose actual shape cannot change seems to change shape with the angle of our view. More often, thanks to shape constancy, we perceive the form of familiar objects, such as the door, as a constant even while our retinas receive changing images of them. Be sure to refer to your textbook for a little more information on the concepts covered today.